So at this power level, it would easily fly continuously all day long. With this little wing just hovering around, we've got no problem sustaining electric power. In fact, the batteries would even be recharging it.
Pulling in more than
it's yeah, the solar panel at this point is collecting probably 3 times, 4 times, even more than that. It's probably collecting 10 times more than we're actually using right now. So it doesn't actually start to pull down those batteries unless we really start jamming on as well.
do a barrel roll.
How many watts of solar is on this?
In ideal conditions, around 400 watts, but you're never going to get that.
Right.
You're rarely going to get that. You have to have directly overhead sun. About that 400 watts.
100 watts is a lot more power than a big screen.
Yeah, but right now we're flying literally probably 50 watts.
Double charging.
Yeah, that's definitely charging. The voltage is sustaining very well.
Yes, there we go. Foster coming in. The drone coming in.
It's a competition. Compliment. Go fire.
Oh, they're friends.
Oh yeah. I don't want to go up too high.
Hello, I would like to show you something I've been meaning to show you for quite a while, but I had to get things squared away at the patent office first. So this is my solar-powered blimp drone. It's still a prototype, it's unpainted and unrefined, but it works. Unlike other drones, this can fly for as long as the sun shines. It's also simple to fly, inexpensive to operate, and, depending on configuration, can have practically unlimited range. Okay, so that's great and all, but why should you care? Because one day, this, or something like it, will change the way the world works. The implications of this kind of vehicle are endless. Natural resource management, wildfire monitoring and response, even package delivery, or something as simple as a farmer monitoring his crops. Resilient and long-range drones will change everything. Okay, so on to the actual design. First off, the envelope itself is constructed of a composite of materials of my own design. Basically, the outer layer is strong and resistant to tearing, and the inner layer is gas-tight. Up here, we have the vectored thrust engine mounts. These can rotate along 2 axes for both pitch and yaw control at low airspeeds. The spars connecting the engine mounts are carbon fiber, so nice and sturdy, but still lightweight. Then we have the electronics compartment. So this houses all the circuitry that controls all the electronics, as well as the radio, the electronic speed controllers, the converters for the solar panels, and finally, the battery. So we don't rely purely on solar power for this design. The battery provides bursts of power when the solar cells don't cut it. Then the batteries are charged by the solar cells when power usage is lower. With a large enough battery and solar cells, you can even fly overnight using this method. For my battery, I use lithium iron phosphate cells instead of the standard lithium ion. Lithium iron phosphate is safer and more reliable and has a much longer lifespan than lithium ion. It does have about 10% less energy density, but in my opinion, the advantages far outweigh that minor loss in energy. Next, we have the solar cells themselves. Now, we have a few options when it comes to the solar cells. This type is best for low altitude work, where you can't rely on having full sunlight all the time. These cells continue to produce power even with indirect or partially obscured sunlight. So when a cloud passes overhead, you still get some power. You could also use high-peak solar cells, which provide higher power in direct sunlight but no power at all in cloudy conditions. That's really best for high-altitude work, where you can fly above the clouds. Currently, I'm running a minimal configuration for flight testing, but you could load as many as 4 times the number of solar cells you see here. And even in this minimal configuration, I have enough power for basic station keeping in good weather. Since, of course, as a blimp, we don't have to expend power to remain airborne. With more solar cells, we could fly in worse weather or at higher speeds. And with the right configuration, we can even fly overnight. So back here you can see the payload. For the payload on this test flight, I've just attached a heavy metal lock and some lead weights. But you could carry almost anything as long as it's not too heavy. Well, anyway, it's still a work in progress, but I feel it has a lot of potential. Thank you for watching, and please let me know in the comments section if you have any questions or suggestions.
Kaldırdıktan sonra dengeyi alırsın hadi.
Hadi başlayalım. Sağ biraz gitme. Ben geri kaldırmaya korkuyorum.
Aslan yüksel.
Hadi başlayalım. Ver coşku ver. Başkanım, başkanım.
İyidir, ne olsun.
Nasıl yemeği?
Bu anı görmek için gelmiş.
Okey, okey. Oldu mu hocam? What we need a little experience.